Okay. In terms of finding angles of elevation and depression, what we need to start off with are two horizontal lines. Two horizontal lines, and then in between those two horizontal lines, we have what we call a line of sight. So our two horizontal lines and then our line of sight. The angle of depression is what I have marked in purple here. The angle of depression goes from the, or between the horizontal line and a line of sight below it. So you're going from the horizontal to the line of sight below that horizontal line would be your angle of depression. All right. The angle of elevation is from the horizontal line up to the line of sight. This is our angle of elevation. And this is between your horizontal line and a line of sight above. A line of sight above. So notice we went from the horizontal line to the line of sight above that horizontal. Let's look at the first example. It says you are measuring the height of a flagpole. You stand 20 feet from the base of the pole. You can see that that information is marked on your picture. You are standing, so you're here. This is you. You're standing like at that point. You're standing 20 feet from the base of the pole. You measure the angle of elevation from a point on the ground to the top of the pole to be 65 degrees. So notice it's elevation. So from the horizontal line up to the line of sight is your angle of elevation. Okay. Our goal is to estimate the height of the pole. Again, you can see everything is marked very nicely in the picture for you. It's not always going to be that way. Once you get into your groups, you guys are going to have to set up all of the pictures on your own. Our goal is to estimate the height of the pole to the nearest tenth. This is really no different than what we did in class last time. It just kind of puts it into a context for you. So with respect to the angle marked, which two sides do we have? The hypotenuse is not one of them. It's the adjacent side and the opposite side is the other one marked. So what uses opposite and adjacent? Tangent. So tangent of 65 degrees is equal to the opposite side, which is h, which is what we're looking for, over the adjacent side, which is 20 feet, and then we can cross multiply and solve. Make sure that your calculators are in the correct mode, and go ahead and multiply that out. Nope, just a tenth is what it says. What are we getting? 42. 42.9 degrees. Oh, not degrees. Hello. Yeah, we're talking about feet here, or meters. Feet. Feet. I know. 42.9 feet is the height of your flagpole. Let's look at the next one then. The height of an observation tower in a state park is 30 feet. So this is going to have us drawing the picture. The height of a tower is 30 feet. So you can draw that much. The height of your tower is 30 feet. A ranger at the top of the tower sees a fire along a line of sight that is at a 1 degree angle of depression. So here's something that is pretty helpful here. If you draw in that top horizontal line, your angle of depression will be in there. It's not actually going to be, your angle of depression is not going to be inside the triangle that we end up using. It's actually going to be in there. Again, your angle of depression is from the horizontal down to the line of sight. So the angle of depression is your 1 degree. So what will this angle measure be? 89 degrees. Very good.
Oh, because that's a right angle.
Yeah, this is a right angle. That's a right angle. Yep.
So will it always not be inside the triangle, basically?
Okay, what else do we have? How? So here's the fire. There's the fire. Does that look like a fire?
For the most part.
Okay. How far is the fire from the base of the tower? So what we're trying to find here is that distance. All right, so now make sure that you are using the angle in the triangle and not the 1 degree angle. So using that angle, which two sides do we have marked? Opposite and adjacent one more time, which lets us use tangent. So tangent of 89 degrees is equal to the opposite side over the adjacent side one more time. To the 10th, we should have that the fire is 1,718.7 feet away. Yes? All right, a 20-foot ladder is leaned up against a building. So let's go ahead and draw that much. Here's my ladder. My ladder is 20 feet long. It's leaned up against a building. Ooh, that picture is so ugly, but that's okay. It says the base of the ladder is 14 feet from the building. So from the building, your ladder is 14 feet away. What is the angle of elevation formed between the ground and the base of the ladder? So the first thing is you have to figure out what angle you're even looking for. Which one's that one? On the bottom, exactly. We're looking for that angle measure. Very good. So if we're looking for that angle measure, which two sides are do we have marked? Hypotenuse and adjacent, so which of our trig functions? So cosine of, let's call that theta. We don't know that angle measure. Cosine of theta is equal to the adjacent side over the hypotenuse. And then to find the measure of that guy, we can take the inverse cosine of our ratio. Inverse cosine of 14 over 20 is what? 45.6. And we are talking about an angle, so that would be degrees.